All right, welcome to another exciting episode of AP Advanced Level Chemistry here at Spain Park. Today is Tuesday, February the 11th, and we're just going to be working on naming ionic compounds, covalent compounds, and acids. So if you're enjoying these videos, Jonathan, tell them what are they supposed to do?
Hit that like, smash that subscribe button, and ring that bell.
There we go. Now you know what to do. All right, so we're just going to take just a few minutes just to review, and then the rest of the time is going to be, let's work on this worksheet, because the only way you're going to get better at this is just practice. So I'm not giving you homework, so we're going to work hard in class so we don't have to work hard outside of class. We're going to work today, we're going to work tomorrow, and you're going to ask any questions and work through these, and the only way to do it is if you work it, figure out, oh man, well, how am I supposed to know this? When do I use Roman numerals? When do I not use Roman numerals? When do I use prefixes? When do I not use prefixes? How do I know which one when? The only way to do that is go through practice problems and then, just get better and better at it. Now, I have as many worksheets on this as you could possibly want. So we're going to start with this. But this naming flow chart, this is your entire chapter. Everything you need to know about naming is right here on this flow chart that I just gave to you. Okay? So the very first thing that we're going to look at is up here, you have your compound, P, X, and Y. Every compound has a positive thing and a negative thing. Okay? So Lucas, will there ever be a negative thing at the beginning?
No.
No. Positive, it's always going to be positive first, negative last, both in name and in formula. And everything only has one positive thing, one negative thing. Now the negative thing could be a polyatomic ion, but it's still polyatomic ions act as a single unit. So we need to be able to recognize it. You have your polyatomic ion sheet. So I would have three things that I have this worksheet that you're going to do. I would have, well actually the periodic table, I would have your ion sheet, and I would have this flow chart. Okay, all these resources. Now you don't get the flow chart on the test, but you get the other different things on the test. You get the test, you get the ion sheet, and you get your periodic table. Okay? So I'm going to look at this. Everything's a positive or a negative. So the first thing that we have to do is identify which of the three things do we have. And the positive thing tells us that. So we ask, now, when I originally did this, these were triangles because in a flow chart, not a triangle, a diamond shape is a question in a flow chart. But I couldn't get that shape on the computer. It was a lot easier just to do a square. Okay, but these are questions that we ask ourselves. So the first thing we say is the positive thing hydrogen? If the positive thing hydrogen, what does that mean the compound is? Yes, so the compound's an acid. And we learned yesterday, right at the very end of class, that the name the acid according to the name of the anion the hydrogen's attached to. Anions end in either "ide," "ite," or "ate." If the anion that the hydrogen's attached to ends in "ide," we're going to go hydro, root word, "it." If it ends in "ite," we're just going to change the suffix "ite" to "us." If it ends in "ate," we're just going to change that to "ic." So this is all of your acid nomenclature. But if the positive thing is not hydrogen, you say no, you ask yourself, is the positive thing a metal, or could it be the one polyatomic cation, NH4+? Is it one of those? If the answer is yes, then it's ionic. So when it's ionic, we have to ask ourselves one more question. Does the P, the positive thing, the metal now, have more than one oxidation state? How do you know the answer to that question? Periodic table, you have to look. If the answer is yes, you have to figure out what the charge is and put it in Roman numerals after the name. And then name the anion last. If the answer is no, it only has one possible oxidation state, you just name the cation first and the anion last. Everything that we did in the notes is all right here. And then lastly, if the answer to both of these is no, the only thing left is for it to be covalent. So then we're going to name the positive first and the negative last, just using prefixes, and here are all the prefixes that you need to know. This is your entire naming unit right here. Everything right here at your fingertips, at your disposal. I'm trying to help you in every way I can. Okay? Use the resources. So now, having that in front of you. Now look, this is the thought process. All of these little squares are just questions you have to ask yourself. This is how, again, remember we talked teaching ourselves how to think. We got to go layer after layer after layer. This is your thought process. This is what you got to go through to get to the right file. Okay? So we look at the practice sheet that I just gave to you. And we can start over here on the right, because this is naming, okay? So I look over here, I want to name each substance. So let's use the flow chart. AuBr3. What's the positive thing? What's the negative thing?
Positive is AU.
AU is the positive thing. Somebody else tell me then obviously what's the negative thing?
Br3.
Br. Okay? Is the positive thing hydrogen?
No.
Not an acid. Is the positive thing a metal?
Yes.
Yes. So what type of compound is it?
Ionic.
Ionic. So you go and you look at gold on your periodic table. Does gold have more than one oxidation state?
Yes.
What are the two possibilities?
+1 +3.
1 and 3. What's the shortcut? Which one do you think it is based upon this formula right here? Most likely it's a 3 because of the reverse crisscross plus 3. Okay? Now, but to double check, what do we know the charge of bromide is going to be based on its position on the periodic table? No. The total is going to be -3, but each one is going to be -1. The halogens are always -1. Oxygen family always -2.
Times 3.
Nitrogen family always -3. So if bromine is -1, but we have 3 of them, that's where we get the -3 to equal 0.
It would also be impossible for it to be 1 because 3 times.
Exactly, but I'm just saying is that the reverse crisscross kind of is an indication shortcut, but you can always double check by making sure that the oxidation number is out to 0. So what would be the name of this compound?
Gold 3 bromide.
Why bromide?
Because I like it.
It's by itself, it's monatomic, there's no oxygen. If it's 8 or 8, there'll be an oxygen with it. It would be BRO, BRO2, BRO3. Okay, so it's going to be gold, 3 bromide. Remember, they can only end in one of 3 things. Ide, or 8. 8 and 8 will have oxygen. Ide is the monatomic. Alright? So I look at the next one. Okay, I got a carbon and I have an oxygen. Is the positive thing hydrogen?
No.
No, so it's not an acid. Is carbon a metal?
No.
No. So that means it's going to be, but it's what type of compound? Covalent, right? So I'm going to name it with prefixes. So do I start the name with mono? No. Okay. So what's the name going to be? Carbon monoxide. Can you see how the flow chart works? Okay? So I go to the next one. So what's my positive thing? What's my negative thing? Potassium's the positive. This whole rest of the thing is negative. So is potassium hydrogen? No. So it's not an acid. Is potassium a metal? Yes. Does potassium have more than one oxidation state?
No.
No. So I'm just going to name the cation first, the anion last. So it's going to be potassium. Then you go to your ion sheet. What's the name of CO3?
Chlorate.
Go to your ion sheet and look at what the name is and don't just guess. Okay? It's not going to be chlorate because that would be a ClO3. Okay? It's carbonate. So it's potassium carbonate. Okay, it's CO3. Okay? It's not ClO3. Okay? So now we look at this next one. This is the last one I'm going to do with you on this side. Is the positive thing hydrogen?
Yes.
Yes. So it's an acid, so hang a right on the flow chart. So then we have to look, well, what's the name of the anion that it's attached to? So you go and you find ClO2 on your ion sheet. What's the name of ClO2? Chlorite. So I say, okay, ite, what do I do with that suffix? So what? It's the root word in us. So what's the name going to be? No, not hydro. Okay, that's going to be the common mistake. You think you need to add always a hydro. When's the only time we're going to use hydro? Look at your rules right there. When the anion is I. Okay? Listen, everybody. Our natural instinct, we don't want to discriminate against the hydrogen. We want to include the hydrogen in the name. But the hydrogen gets included in the name when we say acid. Okay? It's the suffix. The only time you're going to use hydro is when it's an I. Ite in us, you just take root word and change the suffix. So this is going to be chlorous acid. Okay? So you're really going to have to train yourself not to say hydro on all of them. Okay? Because you just want to. It is there. The hydrogen's there. It's just something inside of us. Just, for years and years and years, students always want to put that hydro on there. Okay? So we just got to, again. So, hey, look. Does everybody see how that flow chart works? That's your thought process. You got to go through every time. Now let's do it in reverse. Sodium chloride. Well, what's the symbol in charge of sodium? Na+1. And what's the symbol in charge of chloride? Cl-1. Do I need to do anything? How do I know? And that already equals 0, right? If it ain't broke, don't fix it. All right, now we love these, okay? So first off, is that ionic, acid, ionic, or covalent? This one. Ionic, so I'm just using the ions. But dinitrogen pentoxide, that's covalent, so what do I need to write on that? N2O5. Do I have to worry about crisscrossing, balancing charge, doing anything? No. It's just whatever it is, you're right. N2O5. Okay? Now this one's just kind of a trick. I don't know why they kind of threw that in there. Hey, by the way, okay. Okay. Oxygen. It's O, but it's not just O, it's O2. Okay? I don't know why they put that one in there. Okay? So potassium sulfate. What's potassium? Okay, with what charge? +1. Do we memorize that? No, it's on the periodic table right there. We don't have to memorize. But we know it's +1. And then we look in sulfate. Where do I find that? On your ion sheet. Don't just assume you know what it is. Unless you want to memorize them. So what's sulfate? SO4. And technically it's 2 minus because it's an ion. Okay, if you put -2, again, I'm not going to mark it wrong. It's not wrong. But technically it's 2 minus. So what do I need to do? Cross multiply, because I got to make the positive equal the negative. So I'm going to crisscross, but I don't have to put a 1. So I'm just going to say K2 SO4. Now leave it just like that. Don't worry about erasing the charges or any of that. Leave it just like that. Does everybody understand why we put the 2 right there? So everybody got this, why we put the 2? Because we have to make the charges equal to 0. Okay? So I need 2 pluses to balance out the -2. But whatever this is up here, I'm going to bring it down here without the charge. Okay? Because we never have negative numbers. So I'm bringing the 2 down here and I'm bringing a 1, but I don't have to write the 1. So the whole goal is to make the charge equal to 0. So now I look at sulfurous acid. So we're going to go backwards. First off, it's acid. So what do I know the positive thing is going to be? H. So I go to sulfurous. Sulfurous came from which anion?
I.
Sulfite. So go to your sheet, find sulfite.
SO3.
With what charge?
2 minus.
Since it's 2 minus and each hydrogen is only +1, how many hydrogens do I have to make it neutral? 2. Y'all, if it's -1, you have 1 hydrogen. -2, you have 2 hydrogens. -3, you have 3 hydrogens. So H2SO3. All right? I'm going to skip number 6 and I'm going to go to number 7. This is the last one. What does this Roman numeral 3 tell me?
It's an oxidation rate.
Oxidation of chromium.
No,
Okay.
that's the level.
Say that again. On chromium. So chromium is going to be 3+. Now, if you say oxidation state charge, same thing. Okay? Chromium is going to be a +3, 3+. And then I go and I look at nitrate. So I go to my sheet. Nitrate is, okay, NO3 with a -1. Okay? So now I have to crisscross. Now again, that minus is not on the oxygen. It's not 3 times -1 here. The minus is on the nitrate, the whole thing. So if I have +3 and -1, I have to crisscross. So what does that mean I need? I need 3 nitrates, correct? I need 3 NO3, so how do I do that? Parenthesis, and I put the 3. That's this 3 crisscrossing. This 1 is coming down here. Okay?
That was good 10 minutes.
Alright? So, we good? These are examples of each type. So now let's use the rest of the period and let's see if we can finish the page. Alright? So we'll go over these tomorrow and answer any questions and do some more practice tomorrow. Okay? Those of you watching around the world, okay? You can just kind of maybe use this and do them on your own sheet. Okay? But I promise you, you'll be a better person if you know how to do these. Okay? Y'all have a great day and go Jags.
Is this due for